Hi everyone. So we are talking about some of the control structures. I also wanted to highlight one of the things about sort. We learned about sort in the previous lecture. We can use sort to order a list and assign the result to another variable. For example, here in this one, the let1 array is all these various letters, and then we assign the sorted form of let1 to the array let2. One thing to remember with sorting is when we just use a regular sort, it's always an ASCII sort, but what that means is it results in the lowercase letters appearing after the uppercase letter. Also, the number will sort in a different order than you expect. For example, the 12 will be after 1 or 2 because each position will be sorted. Basically, the numbers will be sorted on the positions. It's not on the numerical value itself. So if you want to sort a different way, like for example, the real numeric sort where you want to have 12 before 102, you need to have different sorting orders. So for that we need to use separate ones, separate parameters. We saw this briefly in the previous lecture. So here I'm going to elaborate it a little bit more as to how to change the sort order. So essentially, as I mentioned, basically to change the sort order, you need to add an argument to the sort function. The argument is a block of code which contains instructions as what is the new sort order. So inside the block of code, we define two variables, which are $A and $B, and these are the variables used to indicate the elements in a list. And then we define a logical operation between these two to denote what is the real sort order. The logic returns one of the three values when comparing A and B, that is 1 if A is less than B, or 1 if A is greater than B, or 0 if they are equal. So assume that this is the given condition. So we use now a specific operator called a space shift operator, which is less than, equal to, greater than, all three combined. It looks like a space shift, so hence it is a space shift operator. This performs the comparison of A and B. The space shift operator essentially returns -1 if the left is less than the right, and 1 if left is greater than the right, and 0 when they are equal. So here is how to use it basically. So the new list is sort A space shift operator, B, and then the list. So this is real numeric value sort essentially. Essentially this works with numbers and it does not work with strings. So just take care when you are using it. But we saw this operator and this how to do a sorting of numerical arrays. At the time we didn't specify this space shift operator in greater detail. So that's the reason why I introduced these slides. So in order to reverse essentially or sort from the highest to the lowest, all we got to do is this invert this. This is also we saw in the previous one. Basically $B, and then you use the space shift operator $A. $A, and if this is the condition, then the list or the new sorted the sorted list will be from the biggest one to the lowest one. So in other words, 102 followed by 12, which is not the number order, but essentially the numerical value essentially. So just keep in mind. Also, Perl has the grep function. The grep function typically searches for patterns in an array, and then the syntax is essentially like this: grep followed by the pattern and then the list. So for example, if you want to find all the elements with pattern day in an array, which is array is defined as Monday, Tuesday, and Friday. Essentially, like when we say like the array list equal to grep, the pattern is always enclosed within the slashes that we already know about, and then base is the array that we are specifying here. This will populate the array result with the matching elements. In this case, all the three will appear in this results as well. So why is so let's see like how it works, how grep works. Basically the grep works by proceeding through an array one element at a time, assigning the element to the default variable dollar underscore. This we know about the dollar underscore, it's pretty much common. Then the pattern to be found is compared against the dollar underscore. So it goes through these two operations. Number one is to assign one element to the default variable, and then it compares the pattern against the dollar underscore, and then once that is successful, then it is getting returned. If the pattern is found, then the expression is true, and then the element is returned by the grep. If pattern is not found, then the element is not returned by grep. So this way we can accumulate that element for in an array. So why is grep important is because now we can do like hash intersections essentially. So one common task in Perl is to find intersection of two hashes or arrays. So means like we built one array from one file, and then we grep to see like whether there is any match. So to find an intersection, the grep function is very useful. So how do we do this? Essentially what we do is so here the problem is to find the intersection between these two arrays. So here we declare another hash called temp, and then we for each of the elements of array we actually create the hash, or essentially like add the elements into the hash array with the index as the array's element, and then the value or actually the key as the array element, and then the value as 1. Now the intersection is fairly simple. The array intersect is same as grep of the temp dollar underscore and then of all the elements in array 2. So for each of them, basically like it finds out what is the value there. So essentially like the code starts by setting up an empty hash for each stores each element in array 1 in dollar underscore 1 at a time, and fills the temp list with them and sets the value to 1. The last line examines the at array one element at a time and sets it to dollar underscore, which is grepped in the hash array temp. If there is it is an intersection element, and that is added to the intersect. So each value, each one from array 2 that's stored as dollar underscore, and that's searched in that array in basically in the hash array, and if it is there, then it returns that particular value, and which is actually stored in the intersect. So this is a very easy way to do an intersection. What if you want to do a difference of two arrays? So all we got to do is we just negate the search condition essentially. So we build the same array. Only thing is like when we do the grep, we do a bang in front of the temp dollar underscore. So this will give you the intersection or essentially the difference between the two arrays. So whichever the element that is in array 1 or array 2 that is not in array 1 will be um, or both of them, that those elements will show up in the at the array intersect. Now I want to introduce you to a new variable which is $bank. So when an error gets recorded by Perl, that error gets stored in a special variable called $bank. So when it is examined numerically, $bank shows a number, but if you are examining as a string, it shows the error message from the operating system. We can use this as part of the die string essentially, like so if can't open and then $bank with the new line. So this statement will display the message can't open followed by the error string from the operating system when the die is triggered. So instead of even bombing out of a program using die, we can simply use a warning to the user, and then the warning messages are conveyed through this warn. So this is again another subroutine with the message, and then it basically gives the warning message. The warn command will display an error message, but the program will keep running. So you can use the warn codes to use the error codes with the warn. Basically, that is the same $bank along with warn. So we talked about the file open, file close. One thing that we did not do in the last lecture was how to test the various files essentially. So what this means is essentially like we can also test whether a file is read only, write only, or whether we are opening a directory, things like that. So this is the similar kind of test that the same that's performed by Unix essentially, that can be done inside of Perl as well. So the usually like this test is done as if -r file, and then this file is predetermined file handle, and then we do some operations. So this particular test basically like the read only essentially tests for whether this particular file handle is a read only file, and this condition has one valid option followed by the file handle to be tested. Alternatively, we can use a file name or a full path of the file name instead of the file handle. So here we are not restricted to just using the file handle. We can also use the full name of the file. So the tests essentially like one of them we can perform, and what are the tests? Essentially there is a whole bunch of tests in Perl. -B is true if it is a binary file. -D tests for whether it's a directory. -E just tests for whether the file exists in the directory, and -F checks if it is a regular file. -M returns the age in days since last modification. -R basically it's if it is readable or not. -S will return the file size in bytes. $T is true if it is a text file. $W is a writable file, and then -W is a writable file, and -Z is true if the file is existing but it is an empty file. So these are all the various tests that we can do in Perl. So we can actually use these tests to verify files when opening or writing. If you are prompting the user for a file name, you can also check to make sure that the file exists. and it is the correct type of data that you want to use it in the program. You can also test to make sure that you're not overwriting an existing file. So now the other operator that you will always find in Perl programs is what is called strict. The Perl's keyword strict is essentially like, it tells the interpreter to use much more care while evaluating or when evaluating statements, and to display the warnings and error messages for everything it finds questionable. Essentially, like, one thing to note is usually Perl will let you get away with quite a bit before actually complaining about something. Using strict is a good way to enhance your programming abilities. To use this one, basically just put use strict at the top of the code. So now let's talk about the Perl debugger. So the Perl debugger, the parts of the debugger is Perl interpreter is a debugger that you can use to examine the execution of the Perl scripts. The debugger allows step-by-step execution of scripts, examination of variable values, and the use of a breakpoint. So these are all like typical use of a debugger, which is also like available in Perl. The debugger is built into every Perl interpreter, and it's activated using the -d option when launching the interpreter. For example, Perl -d my program.txt activates the debugger. When you launch a program with the debugger option, you will see the version information for the Perl interpreter, and then a help prompt. Enter H or quote HH for help. Then the first line of the script. You'll see a message showing which file name the statement is in and what the line number was. Finally, the debugger prompt DB will come up. So at this point, it is waiting for your first debug command. So when the debugger shows you a statement, it's in the cache already to be executed, but it has not been executed. That is the key thing, basically. So it is not executing the statement; it is waiting for you to tell when to execute. Each statement read by the debugger can be examined and manipulated prior to it being run. This allows for some changes or examination of the environment before each statement is executed, which is ideal for debugging the script. Okay, so any valid Perl command can be used at the debugger prompt. You can get help from within the debugger at any time using the H or help command, usually followed by the command that you want information about. For example, the help on breakpoint command, just simply type HB. The command HH shows the summary of available commands and their syntax. So that is like help on help. You can think of it that way. To page the output from the help system, put the line operator essentially in front of the command, such as bar HH. This lets you to page down the system commands. To list the next 10 lines in the Perl script, use the bar command. Every time you issue the bar command, the next 10 lines will be shown. Listing the lines does not affect the line that is being executed. It simply shows you the next 10 lines of the script. The next line to be executed is shown like 3 equal to with greater than sign. You can also specify which lines to show by using a range that is L 10 through 15 is essentially like shows lines from 10 through 15. I think this is the L actually. To run each line one at a time in the debugger, we can use the next command or the N command. Each line is shown on the screen before it gets executed. To see the value of any variable, use the print command at the prompt, which is print $1 will give you the particular value of the variable, and then the current values can be shown without affecting the program. And similar to other debuggers, we can use the N command to step through each line of the program until termination. When a subroutine call is encountered by the debugger in the script, it executes the subroutine as a single call and does not show the lines in that subroutine. To jump into the subroutine and move through line by line, we use the S or the step command. When you issue the step command, the debugger shows each line one at a time executed inside the subroutine, and all valid debugger commands can be used inside the subroutine. So using the breakpoints, essentially, actually breakpoints. Let's look at the breakpoints. We can use the N command to step through the program. Let the debugger run all the lines until the sum condition is met. This is a breakpoint and it is set with B command. We can set a breakpoint at any line number by specifying that particular line number. So for example, B10 will set the breakpoint at line 10, and C or the continue command will let you continue executing after a breakpoint has been triggered. So how do we use, or why do we use breakpoints? So we can set a breakpoint on any line of the script except those that have just the curly braces or closing parenthesis, a blank line, or a comment. Usually breakpoints are used after a loop, subroutine return, or any complex command so that you can verify the action is taken. You can set the breakpoint anywhere except those listed above. To show all the breakpoints that are set in the script, use the uppercase L command. To remove the breakpoint, we can use B command followed by the line number or the subroutine number if the breakpoint is set to the subroutine. For example, D37 will delete the breakpoint that is set from line number 37. And then the reset command, you can reset the debugger to clear all the breakpoints in the variables and restart the execution of the script from the top. Just one command, which is the uppercase R command. Then reset is executed, any defined variables lose their value, and then the first line of the script is to be executed, is the to be executed line. So the built-in debugger is acceptable for simple tracing and debugging. It's not suitable for very complex debugging tasks. Also, it is not graphical. But there are many GUI based debuggers available in the market. Some bundle with Perl distributions, and some are standalone debuggers. The active state Perl distribution has a Windows debugger in the package, for example, and there are several available for Unix and Linux. So I think that's pretty much concludes this half an hour this lecture. We will continue from this point in the next one. Okay, thank you.